Algebra 1, 7.8, we're going to talk about the recursive formulas for our sequences. I made sure yesterday to go back to that chapter 3.5 and talk about the arithmetic sequences. Because if you talk about the arithmetic sequences, we talk about geometric. Arithmetic was when you added or subtracted something every time to get to the next term. We had a common difference. Geometric is you multiplied to get to the next term. So therefore we had a common ratio, R. And if you know A1 and D, or A1 and R, you were able to write those two equations. We call those guys the explicit formulas. They explicitly will allow you to tell me a term of your choice. So, recursive formulas, I got a small definition right underneath recursive formulas, is when you build a term of a sequence from one or more of the preceding terms. It's kind of what you would end up doing to fill in the next three terms. You guys have already done this. I'm going to demonstrate that in a little bit. But before we get to that, I want you to write the formulas from yesterday in the box for the arithmetic and for the geometric explicit. So here, I want you to write that formula for our arithmetic sequence. I want you to write the geometric. So what were those formulas? A sub n equals arithmetic. We didn't actually work too much with it other than just finding a common difference. But A sub 1 plus what's next? You can look back in your notes if you have to, guys. It's the next page right over, right? N minus 1 times D. So if you plug in A1 and D, and then simplify it, right? When you simplify it, it looks a little bit more like slope-intercept form. You're able to then tell me any term of an arithmetic sequence that you want. First term, second term, third term, 1,000th term, 22nd term. Don't really care. Moving on to geometric, the one we actually just learned yesterday, the one we worked with the most, would be A sub n equals A sub 1 again. Ooh, not D, but R. The ratio to the n minus 1 power. So remember, you need A1 and R for geometric. And once you plug those in, you can solve for, again, any term from the first term up to whatever. Those are what we've done. Now we have to do recursive. Now we need to somehow figure out how do you write an equation that builds off of the prior terms. I'm going to turn the page and I'm going to ask you to do something real quick without an equation. What you're going to do is actually, you're going to do recursively in your mind, because it's the easiest way to do this. So here we go. Here's a sequence of 5, 10, 15. Now looks look. It's supposed to be let's. So write the next three terms of that sequence, guys. If I asked you what the next three terms are, this one, and this one. This is an arithmetic sequence, yes? What's the next term? 20. And then 25. And 30. What are you doing? You're adding 5 to what? To what? What are you adding 5 to?
Next number.
Not the next number. You're adding 5 to the previous number. So when you want to get the fourth term was here. You took the third term and added 5. And then to get to the 5th term, you took the 4th term and added 5. I'm continuously taking the term before it and doing something to it. That's recursive. You guys were doing recursive yesterday. Back in 3.5 when I just said find the next 3 terms. Because not too many of us build the formula and then start plugging in 4, 5, and 6, respectively, to find the 4th term, 5th term, 6th term, right? You guys didn't build formulas until I told you to build formulas, and at that point, some of you guys still didn't do it. But this is what you're doing recursively. So how the heck do I state that? How do I build to that point? Well, think of this. Here's your term, right? That's the term I'm looking for. How do I write the term before it? Does anybody know? How could I go about if a sub n is my term now, or the term I want, what would the term before it mean? Okay, think of this. A5. A5 is term 5, yes? What's the term before it? No. What's not the value-wise? What would it be as in A what? A4. And the term before A4 is? A3. And then A2, A1. So if AN is some term out there, what's the term before it? What did you go from 5 to a 4? What did you do?
1.
You subtracted 1. So A sub n and A sub n minus 1 are 2 terms that are next to each other. Would you agree with this? So this is the term right before A sub n. Are they the same? Look up here. Are they the same? No. What did I do? I added the common difference. Do you see that? I took the term before it, and if I add the common difference, I'll get the next term. Let's test this out. Let's test it out. What if I did A5? A5 would be A5 minus 1 plus, wait, what's the common difference of our problem? We didn't do that. Maybe we should. 10 minus 5, 15 minus 10, we end up with 5. So D is 5. Can you guys agree with this? So wait, what is A of 5 minus 1? So it'd be A4 plus 5. If I go to the sequence, do I know what the 4th term is? 1, 2, 3, 4. Should be 20, right? So can I substitute that in? 20 plus 5 would be 25. A5 is 25, is that true? Yeah. It works, guys. Now here's a problem. If I asked you to find the 100th term, what do you need to know?
99.
The 99th term. But wait, to get the 99th term, you need to know the 98th term. Which means you need to know the 97, 96, and all the way down. Guys, there's limitations to this recursive formula, right? This is not the method you would want to use to find the 100th term. You would want to go back to the explicit formula and plug it in, right? So, I'm going to go back. We're going to build this formula into our chart here. This chart, that formula, guys, is A sub n equals, and I'm putting this in the middle of the chart, guys, A sub n minus 1 plus D. This has extra components to it, guys. I call these the wings. I have not parentheses, commas on each side. I act like these are my wings. I need these wings to help me take off. Okay? There's a limitation here. I'm going to put it on the bottom here. Let's find A1. A1 would tell you to do A1 minus 1 plus D. What's A1 minus 1? It'd be A sub 0. Do you know A sub 0? But wait a minute. If I want to know A sub 0, I need to know A sub negative 1. This is a vicious cycle, isn't it? I can't just create something. Something needs to be given to me. And so, this is what I state. I state that you will be given A sub 1. So I put a blank there. You need to state it. You need to state, what's your first term? Because once you know the first term, and you know your common difference, can you find the second? And once you know the second, can you find the third? And then can you find the fourth, fifth, sixth, seventh, eighth? Yes. So you need to state the first term or some starting point. I say start at term 1. Don't start at term 10. Now, if I start at term 1, can I put A1 or find A1 using the formula? No, because if I use A1, I have to find A0. And I don't have A0. So therefore, on the other side, the other restraint or helpful thing, it says that my n values are going to be greater than or equal to 2. If I am given term 1, I have to start at term 2. And go up. Are you guys understanding what I'm saying? So, here's a really cool thing. Both of these equations are based off the same information. They're both arithmetic sequences, right? It was they both were the same equation, or the same sequence of 5, 10, 15, 20, 25. But they're two different ways to write it. They both, looking over here, well actually we didn't write it yet. We didn't write the actual equation. This is what it should look like. So down here, let's actually write it before I explain any more. A sub 1 equals, what's the first term? What's the first term, guys? 5, comma, A sub n equals A sub n minus 1 plus, what's the difference? 5, where n is greater than or equal to 2. That's our equation. But this equation and the one for the explicit formula have the same two components, A1 and D. So wait a minute. If they both use A1 and they both use D, can you switch from one form to the other? And the answer should be yes, either way. Okay, I'm given this equation. A sub 1 equals 20, where A sub n equals A sub n minus 1 minus 3, where n is greater than or equal to 2. Is this an arithmetic sequence? Does it follow what we had? Okay. Is this the explicit or recursive formula? It's the recursive formula. I'm going to ask you to do two things with this. I want you to write the first 5 terms first. So, write the first 5 terms. This is going to take some space, probably about 5 or 6 lines on your paper, but it's not difficult. So, I'm going to start going. A sub 1 equals what? Oh, it's 20. We already know the first term. It's given. A sub 2, though, I have to start using the formula. A sub 2 would equal A sub 2 minus 1 minus 3. Just plugging things in, right? But what is 2 minus 1? So it becomes A1 minus 3. And wait a minute, we know what A1 is. What's A1? 20 minus 3, which is 17. What's A2? 17. Second term. Now, I go to A3. A3 would be A3 minus 1 minus 3, right? And what's 3 minus 1? A2 minus 3. We know what A2 is.
14.
So A2 is 17 and minus 3, which ends up being 14. Are you seeing how this is not a tough process? It's just very cumbersome. It takes a while, especially if I wanted to get to 100. You'd have to do that 100 times.
Yeah,
You guys seeing the power of the explicit formula? Okay. The fourth term, same thing. Do I need to keep going?
Yeah, is it 11 for the fourth term?
The fourth term would be 11, right? Because you just keep subtracting 3. Now, guys, what if I was asking for that 100th term? Or I say, write the explicit formula. The explicit formula for arithmetic sequence is what again? A sub n equals A sub 1 plus n minus 1 times d. What the two things did I need? A1 and d. What's A1? 20. What's d? Not 3, but negative 3. Oh, so you're saying that it's just that? And of course, I don't want to leave it like this because I can distribute that negative 3. So when I go to distribute the negative 3, you get 20 minus 3n plus 3. Can everybody agree with that? Gathering like terms, I'll put the variable first. Isn't it a negative 3n plus 23? Now if I ask you for the 100th term, all you're going to do is plug in 100. That's easy. But guys, guess what we just did? We just went from recursive to explicit. We have to go back the other way sometimes. Here's a problem, guys. If I gave you just this formula, and you guys should recognize that's the explicit formula for an arithmetic sequence. What's A1 and D? Because it's in there, but it's not. What's D? It should be negative 3. Where is the negative 3? Where's the negative 3? It's in front of n. Wait a minute. D was over here, right? I took the D and I distributed to the n. So therefore, whatever's in front of n is the common difference. That's easy to find. But A1 was supposed to be what? 20. I don't have 20 in here. So what's the quickest way to use the explicit formula to find the first term? A1. Guys, what's A1? A1 is negative 3 times 1 plus 23, or negative 3 plus 23, which is 20. You now have A1. You know what D is. You can go and put it into any formula for arithmetic sequence you want. Isn't that cool? took us a little bit to get through arithmetic. I don't think it's going to take as long to get through geometric. Any questions? This one's a geometric sequence. Let's show it's geometric so we can use all the stuff about it. Oops. It's 8 divided by 4, 16 divided by 8, 32 divided by 16. All of those come out to 2, 2, 2, which is R. We found their common ratio, correct? We already know how to write the explicit formula. Let's write the recursive formula. Wait a minute. Wait. We don't have that formula yet. What are we doing to the next term? Multiplying it by 2. And 2 was just R, right? So if I take, and I want to, take some term and I want to find it, I need to again take the term before it, right? And do what to it? Multiply it by R. Now guys, again, I should have wrote a little bit over, but to do this, you still need to know what the first term is, and you still need to state that you're going to start at the next term after 1. Do you guys see how that's the same exact process as last time, but instead of adding to it, you're going to multiply to it. I'm going to go put this into that box. There we go. So a sub 1 equals something, where a sub n will equal a sub n minus 1 times r, where n is greater than or equal to 2. If I wanted to write this equation, we know what a1 is. We know what r is. What's a1 again? What's a1? 4, comma, a sub n equals a sub n minus 1 times, what's r? 2, where n is greater than or equal to 2. You just wrote the equation. And again, if I wanted to write the second term, we'll do that. a2, it'd be a2 minus 1 times 2, which is a1 times 2, which is 4 times 2, which is 8. So the same process, we're just not adding, we're multiplying. Now guys, this equation is really easy to find a1 and r. Because a1's told to you, r is what's multiplied to the term before, which is 2. So if I had to write the explicit formula, there's a1, there's r, I write down the formula, fill it in. Any questions about trying to switch between those forms? Because take a look. a1, a1, r, r. They're really easily, for geometric, they're just out there. The hardest one, guys, is when you multiply d, when you multiply d into this, parentheses, you kind of mess with things and you have to go back and find a1. But even here, d is there, a1 is there. Switching should not be an issue. Finding the first 5 terms of a sequence, showing work, guys, shouldn't be an issue. Guys, your homework is on page 448. Do 1 through 9. Have a fantastic day.